Hello, my name is Omar Alvarado, and today I'm going to show you my investigation about the exploration of microfluidic technology for additive manufacturing, devices for precise material dispensing. Uh, the exploration of microfluidic technology in additive manufacturing. um, the scope is to study focuses on incorporating microfluidic technology into additive manufacturing, reconfiguring a peristaltic pump and a piezoelectric device within Cartesian 3D printing system. This approach will provide precise material dosing, unlike binder jetting technology, using current mechanical and electronics of a FDM printer. It will provide new opportunities in fields like medicine, electronic, and engineering. The 3D printer market, or for FDM, filament deposition technology, is by far the best well-known technology. Binder jetting isn't, despite expiration of its patents. Well-known inkjet printer companies currently uses inkjetting and have excelled in desktop printers, and they uses microfluidic technology for inkjet. If a peristaltic pump is used in 3D printing, the drops aren't or have the qualities for like the binder jetting. They doesn't jet. They just make big drops as shown in this picture. And this is because the surface tension. Surface tension is makes the liquid to stick into the needle, and also another forces like van der Waals forces like cohesion and adhesion makes the drop stick into this needle. If the peristaltic pump continues to work, eventually the water make a bigger drop, and gravity will break the surface tension of this drop and fall. So if we need to make micro drops, we need to think about in micro scale. And in the previous image, we saw the dominant physics like mass and inertia. The peristaltic pump will make this type of macro dropping. So viscosity and capillarity and surface tension are properties that are worthless. So in order to make micro dropping, we need to think about this in micro scale. So we need to break forces like viscosity, capillarity, and surface tension. Mass and inertia are worthless in this type of approach. So how we will make this micro dropping? We can use a piezoelectric device. The importance of consider this approach of microfluidic devices is because in the last 30 years, the number of publications during these 30 years are growing, and only 44, according to Web of Science, only 44 publications are considering additive manufacturing as a tool to make these microfluidic devices, and only 2 publications or papers are considering to use these microfluidic devices into the additive manufacturing. So the materials and methodology are the next. The piezoelectric controller, hoses of different sizes, screws, washer for a peristaltic pump, and acrylic sheets. The methodology was to design, redesign, and manufacture and make adjustments of the peristaltic pump. design and adaptation of the elements of the piezoelectric system within the peristaltic pump. So the development of the peristaltic pump was to use rollers that were described in the previously. Then CAD models were used. We have to make models to make a 3D assembly. Then the pieces were made up of acrylic sheet. And then lastly, the peristaltic pump was assembled. Later on, a piezoelectric system was modeled into 3D. Then, as the previous presentation, the acrylic system was for the piezoelectric. And then as a result of this, monodisperse micromodule was built. The results was what I called a monodisperse micromodule installed into the FDM printer. So the conclusions are the physical properties such as surface tension, capillarity, and viscosity must be understood for the generation of microdrops, and this play the crucial role in achieving this task. The study of these properties and their application represents an approach to find new approaches to additive manufacturing using materials that can be used with this process. Theoretically, the micro monodisperse module would work. However, with each advance, new and unpredictable challenges presented themselves, which need to be solved to advance the research. So time and resources must be considered to address this. And thank you so much.